discuss about decision tree algorithm. So this decision tree algorithm belongs to supervised learning algorithm. So unlike other supervised learning algorithm, this decision tree can be used to resolve our regression and classification problem both. So the general motive of our decision tree is to create a training model which can use to predict class or value of the target variables by learning a decision rules by giving the most prior data. The understanding level of our decision tree algorithm is easy to compare with other classification algorithm. So the decision tree algorithm tries to solve the problem by using the tree representation. Either we can able to make as an internal node or a leaf node. So we have some pseudocode to solve this decision tree algorithm. The best attribute of the data set is the root. So the root of the tree that will be comes under our best attribute. So we need to split the training data set into two subsets. So subset should be made in such a way that each subset contains data with the same value for an attribute. Repeat step 1 and step 2 on each subset. We need to find the leaf node on all branches of tree. So this are all the rules of our decision tree. So let's we go in deeper. So in decision tree, for predicting a class label, we need to start from the root of the tree. We compare the values of the root attribute with the records attribute. On the basics of comparison, we follow the branch corresponding to that value and jump to the next node. We continue comparing our records attribute values with the other internal nodes of the tree until we reach a leaf node with predicted class value. As we know how the model decision tree can be used to predict the target class or the value, now we need to understand how we can create the decision tree model. Assumption while creating a decision tree. So in the beginning, the old training set is considered as the root. So everything will be considered as a root. Future values are preferred to be categorical. If the values are continuous, they are discretized prior to building the model. Records are distributed recursively on the basics of attribute values. Order to placing attribute as root or internal node as the tree is done by using some statistical approach. So when we are choosing a decision tree, we need to follow the representation by sum of the product. So let's see the above example. So when you are getting a decision tree, should I accept a new job offer? Yes or no? This is our thing. So this is our decision node we are calling as, and this is our root node. So root node is if salary at least $50,000. Yes. No. If we will be declining the offer, then we are just commuting more than 1 hour. If yes, we will be declining the order. This is all the leaf nodes. So the first decision node is this. So apart from all other decisions which we are calling as a leaf node. So no means offers free coffee. If yes, we are accepting the offer. No, we are not accepting the offer. So based on the lot of criteria, we will be just going ahead. Let's see with the another example. So this decision tree follow the sum of the product representation. In this image, we can able to see how we can predict. We can able to get the job offer, or we using a computer daily. So we are just going to calculate, or we are just going to come ahead with those kind of product result. It's a sum of product represent disjunctive normal form and a class every branch from a root of the tree to a leaf node having the same class in the conjunction. That's nothing but a product value. Different projects ending in the class form of disjunction. That's nothing but a sum. The primary challenge in the decision tree implementation is to identify the attributes. So do we need to consider as the root node at each level? Handling this is known the attribute selection. We have different attribute selection measured to identify the attribute which can be considered as the root node at each level. The popular attribute selection measures are information gain and a Dna index. So this attribution selection in the data sets consists of n attributes. we need to decide which attribute we need to place ahead. So we can't able to choose the models by the random values. So we need to choose the approach by using some criteria. So when you are planning to choose the attribute by random value, it will give the low accuracy result. So for solving this attribute selection problem, we are just going to solve some criteria like information gain and Dna index. This criteria will calculate the values with each and every attribute. The values are sorted and the attributes are placed in the tree by following the order. That is, attribute with the high value is placed at the root. So how to calculate the root? That's nothing but the attribute which is having the high value. So now we are just going to start with the information gain. By using an information gain as a criteria, we try to estimate the information contained by each attribute. We are going to use some points derived from information theory to measure the randomness of our data, or we can able to go and measure the random variable is defined by entropy, and this is the formula which is used by entropy. So to calculate the entropy, we need to calculate the information gain. So information gain calculates the expected reduction in entropy due to sorting on the attributes. Information gain can be calculated. To get clear understanding of calculating information gain and entropy, we will try to implement it on some sample data. So let's construct a decision tree by using an information gain as a criteria. So this is the sample data which we are having as a criteria. So now we are going to use the sample data. So now we are going to use this data sample. Let's try to use information gain as a criteria. Here we have 5 columns out of 4 columns have continuous data, and 5th column consists of class label. Yeah, so we are having this 4 data, and 5th column consists of our continuous data. Sorry, it's a class label, and apart from 4 it's having a continuous data. So this A, B, C, D attribute can be considered as a predictors, and E column class label can be considered as a target variable. So for constructing a decision tree from this data, we have to convert our continuous data into categorical data. We have chosen some random values to categorize. So I am just chosen A is greater than or equal to 5, is less than or equal to 5 or greater than 5, and B and C and D. So once we chosen this categories, we are going to apply the attribute to calculate the information gain. So calculate entropy of the target. Entropy for each attribute A, B, C, D, E needs to be calculated. Using an information gain formula, we will subtract this entropy from the entropy of the target. The result is information gain. The entropy of target, entropy of every attribute A, B, C, D, E. So needs to calculate using information gain formula, and we will going to subtract with the entropy of the target. So now we are just getting the target variable. We have 8 records with a negative class and 8 records with a positive class. So we can directly estimate the entropy of target as 1. So yeah, here we have a positive and negative. Now we are just going to calculate as 1. So calculating entropy using the formula. So our entropy formula, which is exactly look like this, the target, this is our information gain. So target which we will be getting. So 8, this is nothing but the overall entropy value. So the formula for entropy is, this is our entropy formula, P of x log P of x. So that formula we will be applying here, P of x log P of x plus P of x log P of x. So the variable value we are getting as a 1. So information gain for a variable A we will be calculating. So information gain formula is E target minus E target dot A. So our final output is like this. So now for variable A, we are having actually 12 records. So out of 16 and 4 records with value is less than 5. So how we are just getting is, we already categorize the attribute A, B, C, D, which is having the output like, which is having looks like this. It is belongs to A, and the values which comes with belongs to B, and this is comes to belongs to C, and this comes to belongs to D. So the values which is are greater than or equal to 5, less than or equal to 5, and greater than 5, this values which will comes under your variable A. So 5 and class, positive and negative, how many numbers we are having, and we are applying the entropy. And again we are having another 5 and A is less than 5, and their class we are having in a positive and negative, again we are applying the entropy. So entropy target value is the P which is greater than or equal to 5 into E 5 comma 7, this value, plus positive is greater than 5 into E 3 comma 1. So the final value of this calculation is 0.93. So now we calculated the information gain. So this is the final formula for to calculate the information gain. The same information gain we are applying with our variable B and variable C and variable D. So the final output of your target positive, negative, and target B positive, negative, and target C positive, negative, and target B positive, negative, our output looks like this. So when it comes to target A, we have a 5 positive which is greater than or equal to 5.0, is less than or equal to 5.0, and greater than 5 is 3. So category B, which is comes with this 3.0, will be getting the output like this. So C, our output is looks like this, and D, our output is looks like this. So from the above information gain calculation, which is our root. So this root, that is nothing but this one, B 0.7, because this root is higher than all other roots. So we are taking B as the base root. We should place this attribute on the tree according to their values. An attribute which better value should position as a root A branch with entropy 0 should be converted to the leaf node. So we have a B, so which is greater than or less than or equal to 3.0 will consider as C node, and which is greater than 3.0 which consider as a negative. So the next node we are just considering as a target C, because it is having the less good information gain comparatively for A and D. So then here we are just making for C and D. So the final output we are reaching the positive and negative. So this is how to calculate the information gain. This is how the node is calculating the values. So the next thing is calculating the Dna index. So this is the matrix which is used to measure how often a randomly chosen element would be incorrectly identified. It means an attribute with lower index should be preferred more. So let's reconstruct the index as a criteria. So information gain Dna index, we are going to use the same data sample. So here you are just having the same data sample, and ABCD is the 4 attribute which we created the 4 categorized attribute like this. So now for value A to value D we are going to apply this Dna index. So this is the formula for Dna index. So now for variable A, the values which is all greater than or equal to 5, the positive we are having 5 divided by 12, and the negative we are having 7 divided by 12. So 5 comma 7 Dna index will be calculating for 1, and for this criteria we are going to calculate the another one. And variable B we are having the another is less than or equal to 3. We having a 12 records out of 16, and 4 records with the value which is greater than 5 like this. So now we will be just applying the same formula for our Gini index. So after applying this Gini index formula, this is our target. So the target, we are having A 0.5, B 0.3, C 0.2 and D 0.2. So now C we chosen 0.2 because that is lesser than everything. Then we are just choosing 4.2 our next criteria. Yeah, for C this criteria we are applying, and this is for negative and this is for positive, like this. So then we are going ahead with negative. If it's below this, then we are just having as a negative, and it's above, we are just going for a D. So this D is our second one, 0.27. So let's see the target for 0D, it's 1.4. So here we are giving the value of 1.4. So then again the next target is B. So B target here we given. So this is how your information gain or Gini index is calculating in our decision tree and decision tree. So after we are just calculating this Gini index, we need to go ahead and we need to start to apply this to our data set. So in your Gini index, we having a problem in the decision tree model, that's nothing but a overfitting. The model which is having an issue of overfitting is considered as when the algorithm go deeper, it will reduce the training set error, but the result with an increased test set error. That is, accuracy of prediction of our model goes down. It generally happens when it builds many branches due to outliers or irregularities. So we have two type of approaches for overfitting. One is pre-pruning, another one is post-pruning. So in pre-pruning, it stops the tree constructing bit earlier. It is preferred not to split a node and to measure the threshold value. Post, that is nothing but once you placed everything, after that only it will start to go ahead. So we are using a cross validation data to check the effect of our pruning. So using cross validation data, we can able to expand the node. We can able to come to know whether we need an improvement or not, like this. So when we choosing a two lane and the lane cars moving with 80 km per hour and only one truck is moving with 30 km per hour, and you are the yellow car and you have two choices: keep left and overtake the other two cars quickly, else keep moving in the present lane. So you need to analyze this choice. So either to overtake and able to overtake the car, or you are not going to overtake the car. So for this perspective, you are going to apply the different decisions. So now this target we are just going to calculate based on Gini index or a information gain, whatever itself. So whatever information gain or Gini index, the basic formula we need to apply, that is nothing but our entropy. So now the next step is we need to apply this decision tree to our Python to see how to build the decision tree model in our Python.